Well, now we're up to the second video of the day, some review questions. You know the drill, stopping and starting. Okay, so I mentioned to you guys before that I would suggest you have things like the accumulated interest formula or compounded interest formula in your phone under a folder where you take a picture of it and you put them in a folder for math notes or whatever. So if you have not yet done that, there's your formula. And here's an example of how to apply the formula. You're putting $80,000 in, that's your principal, and it's always 1 plus when it's a savings account. And the interest rate is 6%, so that's 0.06 divided by 12 because this is compounded monthly and there are 12 months in a year. The exponent is 12 times 8. This number will always match here. See how it's n and n? That's number of times in a year. 12 and 12. And then 8 years. So that's 80,000 times 1.005 to the 96th power because 12 times 8 is 96. And that's $129,131.42. All right, so now let's review a little bit. Symmetric, skewing, and what kind of modal situation we have. Okay, so for the top one, exam scores for an exam in which most students did very well, but a few students failed. Well, if that's the case, then when we draw it out, most of the grades are going to be here on the right-hand side, but a few will be out here on the left because a few students did fail. So what that does is it pulls the mean, median, and mode, which would be in this mountainous area, to the left. So it's skewing it to the left. To know which way it skews, just look at where the tail goes. The tail of this graph goes this way. That's to the left, so it is skewed to the left. For the second one, number 4 underneath here, the heights of a group of college athletes consisting of gymnastics team and the basketball team. The gymnastics team does not, well, first off, the basketball team tends to be really tall generally, and gymnastics, you don't see too many tall gymnasts. You know, they tend to be on the shorter end of things. So you can expect one peak for the gymnastics team and a separate peak for the basketball team. 2 peaks. Okay, so we did this question last week, but we did it for tree 1. This time we're going to do it for tree 2, and I'm not going to give you numbers and variables to fill in for the equation of tree 1. It says tree 1 there, but I want you to do tree 2. I changed it to a 2 up here, but I forgot to change it down here. But this should say tree 2, okay? Stop and start. Go ahead. Okay, so y equals, and the x always goes in that place. It's just this is a situation where we have linear growth because they're going up by the same thing every single time, okay? And that is your slope. When you have a constant rate of change, it's linear, so it's y equals mx plus b. The slope that it's going up by is 0.6. And then you have to figure out what was the original equation. And since you're going up by 0.6s, year 0, which is the start, year 1 is not the start, year 0 is the start. So I have to subtract 0.6 from 11.4 and I get 10.8. So it's y equals 0.68 plus 0.6x plus 10.8 for tree 2. Okay, now this is one that gave particular difficulty on the last test that we had. We want to make sure that we're fully aware of how to do this question again. Remember, because we're talking about choices that are all multiples of each other, and we're dealing with 12% no deposits or withdrawals. 96 is a multiple of 12. We know that we're looking at a rule of 72 here, and I think the biggest problem with the last test is I think a number of students tried to use the formula rather than going with the rule of 72. Go ahead. Okay, so I gotta sneeze. Oh, excuse my sneeze. All right. You started with 12,000, and the rule of 72 says divide by the percentage rate. So every 6 years it's going to double. So if you start with 12, 6 years later you've got 24. There's the sneeze I was waiting for. Sorry. 12 years later, you got to double the 24 to get 48. And 6 years after that, you go up to 18 years, and you double the 48 to get 96. So 18 years is the correct answer. I'm correcting my mistake on this one from last time. But of course, I still forgot to correct the animation. So let's just go through this together, make sure we get it. First off, a bond is always for simple interest. So the formula is I equals PRT. The principal is 1,500. The interest rate is 3%, and the years is 8. So 360, 1,500 times 0.03 times 8. I think the mistake that some people made on the test, because the formula is very easy, and there was another I equals PRT question that everybody rocked. I think the mistake people made on the test was not to realize that bonds are always simple interest. So remember that, bonds are simple interest. Anytime you get a bond problem, it should be a simple problem because it's a simple interest problem. If you just remember that. Anytime you get a bond problem, it should be a simple problem because it's a simple interest problem. I think that you won't go wrong if you just remember that. All right, now we want to differentiate between an observational study or an experiment. A group of fly fishermen were asked what was the most productive week of the fishing season is for them. Is this study observational or an experiment? Okay, this is observational. One of the keys to recognizing when something's observational is you look back in time. And that's what the group of fly fishermen do. So this is observational. Another one, each member of a group of fly fishermen were given 5 flies. One fly was a dry fly, one a wet, one a spinner, one a nymph, one a streamer. They were asked to fish each fly for 2 hours and record how many fish the fly caught. Is this a study, an observational study, or an experiment? This is an experiment. Okay, so we've completed our review for today.